Hello and welcome. This is Columbia Basin Research's third video in a multi-part series on using Program Basin TribPit. BasinTribPit is a program created by Columbia Basin Research at the University of Washington School of Aquatic and Fishery Sciences with funding provided by the Bonneville Power Administration. Program Basin TribPit's main purpose is to provide cohort-based survival estimates that account for the possibility of an individual fish overwintering for one or more years or migration periods during the downstream migration process. In the first video in this series, we demonstrated how to find, install, and get the program running, as well as how to load in the necessary data files to use BasinTribPit. And in the second video, we reviewed the parameters of the various BasinTribPit models. Today, in this third video, we will run through using the program itself. First, let's fire up the program. Now in video 1, we went over how to obtain and load in both your observation files and your age files. Please review video 1 in this series if you need a refresher on constructing the necessary files for running BasinTribPit. We'll be running BasinTribPit with those files already loaded in, as seen here. Let's assure we've loaded in our observations data from the previous video, as well as the age data. If you don't have these files, they can be obtained at the CBR website. You can see here the navigation panel on the left side. It lists all the available user actions in the general order in which they should be used, though cohorts should be selected before sites and years. The configuration panel on the right side is used during the model configuration stage. The user actions on the navigation panel are grouped under four main headings. Number 1, Data, for loading the data files into BasinTribPit. Number 2, Configuration, for configuring the releases, sites, and periods. Number 3, Estimation, for estimating the survival-related parameters. And number 4, Results, for viewing reports and graphs. As covered in the first video in this series, there are two types of data that may be loaded into BasinTribPit. Number 1, Observations, and number 2, Age data. Both file types are in comma-separated value CSV format. Note, again, that without an observations file, you will not be able to do anything with BasinTribPit, though you can use the program without an age data file. Configuration constitutes the major portion of the work in BasinTribPit. In the configuration portion, the user defines the cohorts, sites, periods or years, and releases to be included in the analysis. Oftentimes, due to the sparseness of data, some sites and years must be excluded from the analysis to allow the parameters to be estimated. Additionally, the user may wish to redefine the migration period to be more biologically meaningful rather than the use of default calendar years. When observations are loaded into BasinTribPit, a new tabbed window is created for each release in the main part of the user interface. Each release is represented in a diagram with a row for each time period, nominally a year, and a column for each detection site. The time periods and detection sites shown are those observed in the entire data file, including those that may be observed for other releases, even if they weren't observed for the release shown in the active window. Each release is shown on a separate page with the name of the release in the tab for the page. Currently, the release Chl 2010 has been selected and is shown. Chl is the release site, representing a release location in the Chihuahua River, and 2010 is the release year. We will return to the release schematics after looking at the configuration tabs. Notice that the configuration panel has four tabs: Releases, Sites, Periods, and Cohorts. The Releases tab lists the releases, again named by release site and release year, and it shows the number of tags released in each release group. The Sites and Periods tab shows the same detection sites and detection periods as shown on the model schematic. Now let's look at the Cohorts tab. The first step after entering both your observation data and your age data is to navigate to the Cohort tab. This can be done by either clicking on Select Cohorts under the Configuration section of the navigation panel, or else by clicking on the Cohorts tab on the Configuration panel. On the Cohort tab, select the cohort you wish to use. This is important even if only one cohort is listed, because your observations file may include fish from other cohorts. Notice that the release counts on the Releases tab has decreased once I have restricted the data to the 2010 cohort. Let's now return to the model schematic, focusing on the Chl 2010 tab. Again, the schematic shows a diagram indicating where and when tagged fish from the release group were detected. BasinTribPit performs some basic checks of whether the model parameters are estimable based on the current configuration. The text at the top of the window for each tab indicates if the parameters of the model are estimable or not. If unestimable, the text will be red and Fit All Models action will be unavailable. BasinTribPit's estimability check covers the most common reasons that the parameters may not be estimable, but there may be situations in which the program says the parameters are estimable, but the models cannot be fit without further modifying the configuration. This situation will be addressed in a subsequent video. The years are shown on the left, one row per each year. The release year is underlined in green. 55 fish were detected at site WME in 2010 with no removals, and 6 fish were detected at WME in 2011, also with no removals. One fish is known to have passed from WME to TUF in 2010. This one fish may or may not have been detected detected at WME previously. This one fish was detected at TUF in 2010, and it was removed from further analysis downstream. Removals can happen because fish passed through a sampling room at a dam, were known mortalities, or were collected for transport at a transport dam. If there is a colon, the number of fish detected is indicated to the left of the colon, and the number of fish removed is indicated to the right of the colon. 0 fish were detected at TUF in 2011. Ultimately, all parameters for every release must be estimable before the Fit All Models command on the navigation panel is available, allowing the user to estimate parameters for each model. To estimate the model parameters, the user may need to remove some years and detection sites from the analysis because of sparse data. Again, I can uncheck any release groups, sites, years, or cohorts I don't wish to include. You can see here in periods that I'm unchecking 2012, 13, and 14 because no tags were detected in those years. I then must hit apply to completely apply the change. An alternative way to remove sites and years from analysis is via the context menu. I can right-click on MWE here and then select Remove Site MWE, or I can right-click on the years to remove whichever year I'd like to remove. Note that due to how the context menus are created, the user may have to right-click twice. If your data set includes multiple release sites, those release sites either may occur all upstream of the first detection site, or some may occur upstream and some downstream of that site. Because the first reach represented by different releases will not necessarily include the same stretch of river or may only include a partial reach, BasinTribPit uses unique beta parameters to represent survival and movement from release to the nearest downstream detection site. A consequence of the flexibility of BasinTribPit in allowing multiple upstream releases and allowing releases from sites that are not detection sites is that there can be more than one possible interpretation of a given data set. One way this may be realized is in identifying the primary detection site. BasinTribPit defines the primary detection site as the first detection site downstream of the primary releases. By default, BasinTribPit sets the primary detection site as the most upstream detection site that is downstream of all included releases. On the configuration page for each release, the primary detection site is listed. Since MWE is the most upstream detection site shared by all 4 releases, it is set as the primary detection site by default. Note that CHL is listed among the sites, but is not checked by default, and it does not appear in the detection schematics. This is because CHL occurs downstream of the Chl, the release location, but upstream of the location assigned to the Chl release site. Because CHL is not checked, all detections at CHL are ignored and it is not included in the model. Both Chl 2010 and Chl 2010 are considered primary releases since they are both upstream of MWE. Although Chl 2011 and Chl 2011 are also upstream of MWE, they are considered auxiliary releases because they were released in a later year. The user may decide to use CHL detections by checking the CHL box on the Site's Configuration tab. This also changes the primary release group to Chl 2010 only, and now Chl 2010 is considered an auxiliary release group because it was released downstream of CHL, the primary detection site. For the rest of this example, we are going to omit CHL and use MWE as the primary detection site. There were very few tags detected at LWE, RIA, or sites downstream of MCN. In order to fit the model, it is necessary to remove LWE and RIA and to set JDA as the last site. This has the effect of pooling detections from JDA and all sites downstream of it, in this case BON and TWX. Note that removing a site or year for one release has the effect of removing it for all releases. By default, BasinTribPit uses the calendar years for the periods. The user has the option of changing the periods to more biologically meaningful periods. We will demonstrate this in video 5 of this series. I can save the current configuration so that it can be reloaded into the program later. To save the configuration, go to the File menu and select either Save or Save As. The program will show a default file name and location that can be changed to your preference. To restore a previously saved configuration, go to the File menu, select Open, and then select the configuration file to be loaded. BasinTribPit does not save any parameter estimates, only the current configuration. If you should want to clear your various data files from BasinTribPit's memory, click Data and Clear All Data, and then Yes. Sorting through all of the previously mentioned steps will allow you to properly configure the program. In the next video, we'll move on toward generating and interpreting your results. This has been lesson 3 on using Program Basin TribPit, in which we covered how to configure the program to suit your needs. Further videos in this series will take a look at the results generated by BasinTribPit and offer further tips on getting the most out of the program. If you're using BasinTribPit and you have any questions or comments, you can fill out the user satisfaction survey as mentioned in the YouTube notes. We would greatly appreciate any feedback you have in helping make future versions of this program to be more helpful to our users. We hope that this video helps you get the most out of the program BasinTribPit. Again, if you have any questions or comments in regard to the program, please fill out our survey. You can also contact Columbia Basin Research at web@cbr.washington.edu. Best of luck with your survival models, and thank you.